The X-59 is an advanced research aircraft developed by NASA in collaboration with Lockheed Martin's Skunk works. Its main purpose is to address the challenge of sonic booms associated with supersonic flight.
The world is on the brink of a new chapter in aviation history, one where supersonic flight makes a triumphant return, but without the earth-shaking sonic booms that once haunted it. At the heart of this revolution is the X-59, short for Quiet Supersonic Technology, a futuristic jet born from a collaboration between NASA and Lockheed Martin's Skunk Works division. This experimental aircraft is redefining what it means to fly fast and quietly. With the X-59 preparing for its maiden flight in 2025, both aviation enthusiasts and global superpowers like China and Russia are watching closely. But what exactly makes the X-59 so special? Why does it matter, and how could it change the way we fly forever? Let's take off into the story of a jet that's bringing back supersonic speed with a whisper. Supersonic travel without the boom. For decades, the main hurdle preventing supersonic passenger flights over land has been the sonic boom, a thunderous noise caused when planes break the sound barrier. This deafening crack isn't just startling, it's disruptive and has led to strict regulations banning supersonic flights over populated areas. The X-59 aims to change that narrative. Instead of a loud boom, the X-59 is engineered to produce a gentle sonic thump, akin to the sound of a car door closing. This breakthrough could pave the way for quieter, faster travel across continents, without the noise complaints that grounded the dreams of past supersonic jets like the Concorde. A jet with a mission. The X-59 is not just a fast jet, it's a flying laboratory. Developed as part of NASA's low-boom flight demonstration program, it is specifically designed to test how people on the ground perceive its noise. If the thump is considered tolerable, it could lead to new regulations allowing commercial supersonic travel over land. Built by Lockheed Martin under a contract awarded in 2016, the X-59 is the product of years of meticulous research, wind tunnel testing, and cutting-edge engineering. By 2025, the aircraft is expected to begin flying over select communities in the United States to collect feedback on its sound signature. Designed for silence and speed. Measuring roughly 100 feet in length and weighing around 32,000 pounds when fully loaded, the X-59 is built for both speed and stealth, at least stealth and sound. It's powered by a General Electric F414 engine, the same beast used in military fighter jets. This engine delivers around 22,000 pounds of thrust, pushing the X-59 to speeds up to Mach 1.5, or about 990 miles per hour, while cruising at an altitude of 55,000 feet, nearly twice the height of most commercial aircraft. But here's where it gets fascinating. Unlike traditional jets that have engines mounted beneath the wings or on the tail, the X-59's engine is mounted on top of the fuselage, tucked toward the center. This unusual configuration is a deliberate move to prevent shock waves from merging, thereby eliminating the loud sonic boom. A windowless cockpit. Almost. Another standout feature of the X-59 is its lack of a traditional forward-facing cockpit window. Because of the aircraft's sleek, needle-like nose designed for aerodynamic efficiency, there simply isn't room for a front window. Instead, pilots rely on NASA's external vision system, a sophisticated setup that uses a 4K front-facing camera combined with cockpit displays to offer a synthetic forward view. This digital windshield ensures the pilot can safely navigate while maintaining the jet's ultra-streamlined design. Born from the legacy of Concorde. To appreciate the X-59's innovation, we need to revisit its famous ancestor, the Concorde. When it took to the skies in the 1970s, the Concorde was a symbol of progress, capable of flying from New York to Paris in under 4 hours. It cruised at Mach 2.2, over 1,330 miles per hour, and soared at 60,000 feet, high enough for passengers to see the curvature of the Earth. But the Concorde's reign was short-lived. Between sky-high development costs, limited range due to noise bans, and a tragic crash in 2000, its commercial viability faded. By 2003, both Air France and British Airways retired their fleets, ending an era of faster-than-sound travel. The X-59 seeks to learn from those mistakes. Where Concorde roared, the X-59 intends to whisper quiet enough to gain approval for overland supersonic routes and efficient enough to possibly one day serve as a blueprint for a new generation of passenger aircraft. engineering challenges, and triumphs. Creating a quiet supersonic aircraft is no small feat. Engineers had to rethink every aspect of aerodynamics and engine placement to avoid the classic boom. To validate the design, Lockheed Martin began by building a 9% scale model of the X-59 and conducted extensive wind tunnel tests from 2017 onward. These tests simulated everything from subsonic to supersonic flight, ensuring the full-scale aircraft would perform as expected. One of the trickiest parts was ensuring smooth airflow into the top-mounted engine. Because the engine sits behind the aircraft's long nose, the air that reaches it can be turbulent, potentially disrupting performance. Engineers had to shape the air ducts and body with extreme precision to keep the flow smooth and steady. Advanced technology with proven parts. Despite being a cutting-edge experimental jet, the X-59 does not start entirely from scratch. To save time and ensure reliability, engineers borrowed components from proven military aircraft. The cockpit canopy, pilot seat, and landing gear are derived from planes like the F-16 and T-38 Talon. The airframe and avionics, however, are all new, tailored specifically to minimize shock waves and maximize stealthy sound. Heat, altitude, and pressurization. Like the Concorde before it, the X-59 will deal with intense heat buildup from air friction at supersonic speeds. Every surface, from the fuselage to the windows, will experience kinetic heating, a challenge that requires carefully selected materials and rigorous testing. At 55,000 feet, the air is thin, meaning the cabin must be highly pressurized to ensure safety. If the pressure were lost suddenly at that altitude, even the fittest passenger could lose consciousness in just 15 seconds. As such, NASA has incorporated redundant safety systems, including advanced pressurization and oxygen supply solutions. Public testing and the future of supersonic travel. Once flight testing begins in 2025, the X-59 will fly over several pre-selected U.S. communities, where volunteers will be asked to evaluate the noise levels. These community response studies will help determine whether people find the sonic thump acceptable. If successful, this data will be presented to regulators like the Federal Aviation Administration and the International Civil Aviation Organization. The goal is to shape new global noise regulations by 2028, potentially unlocking a future where supersonic jets can crisscross entire continents in half the time. A strategic edge and global impact. Beyond civilian travel, the implications for national defense and aerospace leadership are enormous. Supersonic, low-boom aircraft could be adapted for military use, enabling high-speed operations without alerting adversaries with a boom. It's no surprise that nations like China and Russia are closely monitoring the X-59 program. Whoever masters quiet supersonic travel first won't just transform transportation. They'll gain a serious edge in both economic and strategic terms. Final countdown to the skies. As of early 2025, all major components of the X-59 have been assembled. Engine testing wrapped in late 2024, and the aircraft is already rolled out of its hangar, awaiting its historic first flight. If it succeeds, the X-59 could unlock a new era of faster, quieter, and more efficient flight, dramatically shrinking travel times across the globe. Imagine flying from Los Angeles to Tokyo in under 6 hours, without ever needing to fly over an ocean to avoid making too much noise. That's the future NASA and Lockheed Martin are building. One quiet thump at a time. And that's a wrap on the future of flight. If you enjoy diving into the next generation of supersonic jets and want to stay updated on all things cutting edge in aviation, don't forget to smash that like and subscribe. Until next time, keep your seatbelts fastened, your curiosity flying high, and we'll see you in the next video.